Good afternoon, everybody. My name is Ahmed Seidu from Ghana, northern region of Ghana. I'm a student of University for Development Studies and the staff of CSIR-SARI, where I am a technologist under the crop protection and entomology. My supervisor is the supervisory team is made up of Professor Kezumeku from the University for Development Studies, Dr. Mumuni Abudullahi, co-supervisor and a former PI of TMO, and Prof. David Jordan from US. By way of introduction, peanut or groundnut is an important source of food and feed to we human beings and animals. It is consumed as peanut butter, groundnut oil, confectionery snack, roasted salt or sweets, and also used in soups. It is produced in all agroecological zones of the country, but predominantly in the northern part where I lived. About 80% of the groundnut produced in the country coming from this part of the country. Its production also improves the fertility status of the soil and serves as an excellent rotation crop with the cereals such as maize and the sorghum, where this part of the country peasant farmers always use. So, however, its production is constrained by pests coupled with the use of unimproved and low-yielding varieties. Consequently leading to low yields, sometimes as low as 400 kilograms in these less developed countries compared to about 300 or more, 3,000 or more kilograms per hectare elsewhere, such as the US. Moreover, pest damage to pods leads to aflatoxin contamination with its negative impacts on the health and the international markets. The damage on the pods pre-exposes these pods to this Aspergillus flavus contamination on them, leading to this aflatoxin contamination that renders the pods less quality and health impact. Objectives of the study is the main objective is to determine the effects of location and the time of planting on peanut yields and quality in the country. The specific objectives of the study are: one, to assess the impact of geographical location on soil arthropod pest and yield of the crop. Two, to determine the effect of planting time on soil arthropod pest abundance and yield of the crop. Three, to assess the resistant levels of an improved variety, which is Sarinut to soil arthropods. And lastly, but not the least, the combination of the above mentioned crop. Materials and method, the experimental site. The original plan of the study was to conduct it on farm using farmers at different locations where groundnut is cultivated intensively in the northern region. But due to the onset of COVID-19, it was agreed that the research should be conducted on stations of the Research Institute of the Council for Scientific and Industrial Research, which is 1, Wa, 2, Nyankpala, and 3, Kumasi. Nyankpala and Wa is in the northern region under the CSIR-SARI catchment area, and Kumasi is under the crop research catchment area. The northern region is noted as being unimodal rainfall, whilst southern Ghana has bimodal rainfall patterns. Experimental design, the experiment was a 3x3x2 factorial using split with locations as the main plot, time of planting as subplot, and variety as subplot, with 3 levels, 2 levels, respectively, leading us to 18 treatments per rep, and this was replicated 4 times at each location. Experimental procedure: the land was plowed and harrowed by a tractor before planting, and a plot size of 5 meters by 5 meters was used with 1 meter and a 2 meter alleys between treatment plots and replications, respectively. using Chinese and Sarinut as the varieties. And these are early, medium duration maturing varieties, respectively. Chinese had a duration of 90 days, and the Sarinut had a duration of 105 days. Respectively. The varieties were spaced at 0.5 meters respectively, and the planting was done at a depth of 0.04 to 5 meters deep, and weeds were controlled manually using the hand hoe. Data collection comprises preliminarily of the cropping history of the first, where 2 years information was taken, and before planting, and baseline and the post harvest were taken before planting and after. Associated insect pests, and using samples of the plants, 5 plants from each treatment plots, where the plants were dug around the plant, and the plant were lifted gently to assess for the presence of these insect pests. Pores per plant were also taken by taking 5 plants randomly from the plot and counting the number of plants produced by the plants, and this was then used to calculate the pod yield for each treatment. Data that was taken was then subjected to ANOVA using Gen Statistical Package 12 edition, and the means were separated using standard error of difference at 5% level of probability. Results and discussion. An interaction effect of location and variety on termite per plant was significant. And it was seen that Chinese across all the locations had recorded more termites per plant compared to Sarinut 2. Significantly, Chinese recorded high termite per plant compared to Sarinut 2 across all the locations. And Sarinut 2 had the least. It was also observed that at Fumesua, that is Kumasi, Chinese had the highest compared to Nyankpala and Tanina. The opposite happened with regards to Sarinut 2, where we have the highest termites per plant recorded at Tanina and the least at Fumesua. Interaction effect of time of planting and location on termite per plant at harvest was also recorded. Across all locations, it was agreed across all planting times. It was seen that recorded that Fumesua had the highest termites per plant, with the exception of the early May planting compared to the mid-May and the early June planting. But with regards to Nyankpala and Tanina, it was the mid-May planting that recorded the least termite per plant compared to early May and early June planting. Second order interaction of location by time of planting and variety on millipedes per plant at harvest was significant. It was seen that Fumesua recorded the highest millipedes per plant during the early May planting with the Chinese compared to Sarinut 2, and it was the highest across all the planting times. Compared to, it was the highest in the early May planting compared to mid-May and early June planting. Sarinut 2 was seen to have low records of millipedes per plant across all the planting time, with the exception of that of Kumasi. Main effect of the main effect of location on wild worms and the white grubs was significant. White grub per plant at harvest was seen to have high records at Nyankpala compared to Fumesua and Tanina, where Fumesua had a low records of white grub. While worm were also high rather at Nyankpala compared to Fumesua and Tanina, with the list being recorded at Fumesua. That was also the main effect of time of planting on white grub and the wild one, which was significant at harvest. We have white grub being significantly higher at early planting compared to that is early May planting compared to mid-May and early June. But it was significantly different from that of the early June planting, which was the last planting, where worm was also seen to have high records of where worm was seen to have recorded on the early June planting compared to early May and mid-May, with the list being recorded